the maximum amount of charge that can be stored by the conductor. Okay.
Yes, sir.
So if we want if we want to increase the capacitance, if we want a device whose capacitance is large means that device can store a large amount of charge. And if we want to store a large amount of charge, then then we have to make a device. We have to make a device, and someone made that device, and that device is known as the capacitor. That device is known as the capacitor.
Capacitor.
So the work of capacitor, the use of capacitor is to store the large amount of charge. Okay, to store the large amount of charge. So why we required the capacitor? Because if you want to store the large amount of charge, then you required some device, and these kinds of devices store large amount of charge. So this is the reason why capacitors are made. Capacitor. So capacitor is nothing. Capacitor is nothing but what you should do. Take two conductors. This is one conductor, and this is conductor, so charge will be on the surface. Charge will be on the surface. Okay. So charge will be on the surface, and take another conductor You can take any conductor of any shape, another conductor, but this time you take the charge on the conductor should be negative, and this system is separated by some distance. This system is separated by some distance, some small distance. Okay. This is a small distance, and there is some medium in between these conductors. There can be medium means, suppose this is one conductor, this is another conductor, and they are separated by some distance, and in between these conductors now air is present. So any medium can be present in between the conductors. So this is the capacitor, and generally these are separated by some dielectric medium.
Yes, sir.
Your medium is
Dielectric medium.
Separated by some medium. So definition of capacitance, you can write capacitor, right, a device used to store large amount of charge. Large amount of charge. Simply you can say it consists of two opposite charged conductors separated by some medium. And medium can be medium can be air and some dielectric, air or some dielectric medium. Okay, and right here. Generally, you will see we will introduce in being the capacitor air or dielectric. And dielectric is something which is not conducting. Dielectric is something which is a non-conducting material. Non-conducting material. Like mica and all these things. So dielectric is non-conducting material. And symbol of capacitance is simply like this is the symbol of parallel plate capacitor. Or the you can say the symbol of capacitor is like this. So this is capacity. So there is a question. A charge of plus 10 coulomb is placed at the center of a sphere at the center of a sphere. Calculate number 1 surface charge density. Surface charge density means sigma. Second is capacitance of sphere. So we have to calculate this. So suppose this is the sphere.
Yes, sir.
And I have told you when, and remember this thing that this sphere is conducting sphere. So when you place the charge here, what will happen? The charge will spread on the surface automatically
Surface.
on the
Yes, sir.
surface due to the induction. Okay, now we have plus 10 coulomb charge on the surface of sphere, and this sphere have the radius of 0.1 means you can say 0.1 meter radius. This is r, and in the question it is given. So r is equal to 10 centimeter. So first convert r into meter. 10 centimeter divided by 100, it will become 0.1 meter. And first question is, or first answer first is surface charge density sigma. Sigma is equal to what is sigma? Sigma is charge per unit area.
Charge. Yes, sir.
And charge is 10. And area of sphere 4 pi r square.
Yes, sir.
4 pi r square, and this will become 10. 4, we know the value of pi is 3.14, and r square means 0.1
Whole
square. When you calculate this, you will get the answer like I think 79.6 coulomb per meter.
meter square.
You should check these calculation at
Yes,
your
sir.
home.
Yes, sir.
And another thing is capacitance of sphere. We know for a spherical conductor, the capacitance is 4 pi epsilon naught r. I have discussed earlier. C is equal to 4 pi epsilon naught for sphere.
Yes, sir.
So
For a
we
sphere.
have 4. This is 3.14. Epsilon naught is 8.85.
8.85 into 10 raised to
12.
minus 12, yes.
R is given as 0.1, and when you will calculate, you will get the answer 11.11 into 10 to the power minus 12.
Minus 2.
Correct. So these kinds of questions you can get in your examination.
Okay, sir.
And now we will study 3 types of capacitors. Number 1, parallel plate capacitor, spherical. We will study only one type of capacitor, but there are 3 types of capacitor. We will
Parallel
see that.
plate, spherical, and then.
So please note it down first, then
Yes,
we
sir.
will move. Should I scroll down, Harsh?
So just a minute.
Okay, no problem.
Yes, sir, you can scroll down.
And I have already told you, for the conductors, we always take the surface charge density because charge is only on the surface.
Surface.
And you should remember the formula.
Yes, sir.
Capacitance C is equal to 4 pi epsilon naught
Not R.
R for the spherical
A
conductor.
spherical conductor. Second, just scroll down.
Now it's okay.
Yes, sir.
Okay.
Done, sir.
Right.
Yes, sir.
So now another question. Battery and capacitor, both the devices used to store the charge. What is the difference between these two? Like we have batteries in our phone. We know what the battery is. We have
Yes, sir.
batteries in our phone. So battery is also used for storing the charge, and capacitor is also used for storing the charge. But here we have to tell what is the difference. So difference is like during the charging, both devices behave same. There is no difference during the charging. When you charge a battery, when you charge a capacitor with some power source, then there is no difference in the behavior. But the discharging of capacitor and discharging of battery is very different. Like the battery discharges gradually, means slowly. The battery discharges slowly. Like the battery of your phone discharges instantly or slowly,
Slowly,
gradually,
slowly,
slowly.
slowly.
But you can imagine like flashlight of camera. Flashlight of camera is example of capacitor. Means the capacitor is connected to that flashlight of camera. So you have seen that when you open the flashlight, you turn on the flashlight, and when you again press the button, it instantly switch
Turns
off.
off. Yes, sir.
So this is the, so means there is a system connected which is capacitor. So answer is during discharging. First, right, during charge, both behaves both same. But during discharging, during discharging, capacitor discharges very fast. Within a fraction of second, it discharges. Capacitor discharges instantaneously. Instantaneously, or you can say within a fraction of second. Fraction of second. Fraction of seconds. But in case of battery, discharges gradually, means slowly. And here the example is flash light of camera, and here bulb connected with battery. Suppose this is a bulb and this bulb is connected with some battery. Yeah, this bulb is glowing constantly. And this is battery. So please note down, Harsh.
Sure.
So this is just a general question, just for the interest.
Done, sir.
Done.
Yes, sir.
Now the main topic. Capacitors are of three types: parallel plate, parallel plate capacitor, spherical capacitor, spherical capacitor, cylindrical capacitor, cylindrical capacitor. But not in your syllabus. But these are in the syllabus of NEET and JEE. Okay. So if you will
Yes, sir.
prepare for JEE, do you have biology or mathematics in 12th
I
class?
have biology, sir.
So if you will give the examination of NEET, do you NEET exam? There is some exam for doctors.
Yes, sir. There is need.
Yeah. So in NEET this is included, but in CBSE this is excluded.
Yes,
So
sir.
parallel plate. So our main focus is on the parallel plate capacitor. So we will do number of things with parallel plate capacitor. Okay. So now first is I am writing the heading parallel plate capacitor. First you will see what is parallel plate capacitor. Parallel plate capacitor is like from the name you can understand. Parallel plate, see here or see here. Parallel plate is like this. This is a
Yes, sir.
this is one plate, this is one plate, and these are parallel. Parallel means making 0 degree angle with each other, not like
Yes,
this,
sir.
not like this.
Yes,
These are placed like this, and
yes.
there can be any medium in between these plates. But the thing is that one plate is positive charge and another plate
And
is
other is
negative,
negative charge. Negative
negative
charge.
charge. Because we know that what capacitor is. Capacitor is simply the combination of two conductors which are oppositely charged and they are separated by some distance. Now suppose these plates are separated by distance d. These plates are separated by distance d. And remember one thing more. Remember one thing. A is the area of both the plates. Means both plates are of same area. Area of both plates. Like I am drawing only one plate. Like this is the plate. Okay. So area will be like this. You can say this is length and this is breadth. So area is equal to L into this is the area of the plate. This is the parallel plate capacitor. Now, number one is capacitance. Now, this is capacitor. This is capacitor. So now we will calculate the capacitance of parallel plate capacitor. Capacitance of parallel plate capacitor. And Harsh, one thing I am going to tell you, and this thing is very, very important. Very, very important. Maybe you have studied in your electrostatics from some other teacher. I don't know. But I am telling from my side because this will be used very much. Suppose there is any plate. This is positively charged plate. And this have a sigma is surface charge density.
Surface density, yes, sir.
Surface charge density. And from the surface of this plate, if I want to calculate the electric field at any distance E, this E is equal to sigma y 2 epsilon naught. Always remember, if I calculate this electric field here, here also the value of electric field will be same. Okay. So electric field is constant nearby this plate.
Okay.
So you can note this down. Constant everywhere. Not everywhere means you can write constant.
Near the. Okay.
Accordingly you can. So sigma by 2 epsilon naught, this will be 2. And if negatively charged plate, if I am taking a negatively charged plate, and I want to calculate electric field at any point, so E will be again sigma. If I am talking about the magnitude, so in magnitude we will not take the sign now. So this will be
Yes, sir.
sigma by 2 epsilon naught. I am not taking a negative sign because this is the magnitude. So please write this. E is electric field. E is electric field. Please note it
Yes,
down.
sir. Yes, sir.
This first. And after that, we will drive the capacitance of parallel plate capacitor. The main thing here is to calculate the electric field for calculating the capacitance, net electric field between the plates. And you have seen this as infinitely charged plate and calculate the electric field at a distance r. For that, what you will do, you have actually you have studied this in the electrostatics when you are studying the Gauss law, and you draw the Gaussian surface. Like for this, the Gaussian surface is cylindrical surface around
Yes,
it,
sir.
symmetrical
Cylindrical. Yes. Yes, sir.
cylindrical surface, and you use the Gauss law, and with the help of Gauss law and electric flux, uh, you calculate the electric field. So this is the result from there. You can revise your notes as you if you want this in detail.
Yes, sir.
Completed.
Sir, done, sir. Done. Yes, sir.
Okay, so now I am just removing this. There are many other ways to remove this. When air is in between the plates. Now these are two parallel plates, and there is the air in between the parallel plates,
Yes,
air
sir.
or vacuum, air or vacuum. So I am copying this diagram. So now we'll make it bigger. So this is our capacitor. This is our capacitor, and we are taking now it's okay. So we have two parallel plates, and area of each plate is A. We have already discussed area of each plate. This plate have surface charge density of sigma. This plate has surface charge density of minus sigma. So you can say this plate have a charge of plus q, and this plate have a charge of minus q. No problem. So Harsh, now we will calculate the electric field outside this plate here. We will calculate the electric field in between the plate, and we will calculate the electric field at three locations. Suppose this is location P, and this is location Q, and this is location R. Now look here very carefully. Look here very carefully. So Harsh, due to this negatively charged plate, if I only ask you, if I want to ask you, what is the direction of electric field due to this plate at this point? The direction of electric field is in this direction.
Yes, sir. From negative to positive.
I am supposing this as plate 1 and this as plate 2.
Yes, sir.
So this is the direction of E1.
Yes, sir.
And due to this positively charged plate, the direction of electric field at point R is in this direction, E2. And we know that we have discussed E1 and E2 are equal in magnitude.
Yes, sir.
Means here are two vectors which are in opposite direction. Means net electric field here is zero.
Zero. Zero.
So
Net field is zero.
E net electric field at point R equal to 0. So here the net electric field is 0. Now calculate here. Due to this, the direction of electric field E2 is here, is like this. And due to this plate, the direction of electric field will be like this. And we know that E1 is equal to E2. I have already discussed in magnitude. If we talk about the magnitude, E1 is equal to E2 is sigma by 2 epsilon naught.
Yes, sir.
So here also E net at Q equal to 0. Means there is no electric field here, there is no electric field outside the plate. Now we will calculate the electric field inside. If there is no electric field inside, means we cannot store the energy. So now here we will calculate here electric field. So Harsh, at this point we due to this plate, the electric field is in this direction.
Yes,
E1.
sir.
E1. And due to this plate, the direction of electric field is again in this direction, because this is positive, and at this point the electric field is in this direction, na? E2.
Yes, sir.
Now you are confused, I think. See here. This is a plate, na, positive charge, and I want to calculate the electric field here. So whenever someone says you to calculate the electric field, consider there in your mind there is a positive charge placed. Positive charge placed, and this positive will repel this positive, means the direction of electric field like this. So this is positive charge, and here is positive charge, means the direction of electric field E2 is in this direction.
Yes,
Okay.
sir.
So E net at point P, and we know that P is a point which is in which is in a region between the plates.
Sir, you're lagging.
What? Oh yeah.
You're lagging, sir.
My internet connection.
No, it's actually my internet connection showing my internet is lagging, so this.
My internet connection is weak or yours?
My sir, mine.
Okay, no problem. So now it's okay, or still my voice is lagging?
So now it's okay, sir.
So point P is in the region of capacitor, in the region of two plates, in the region of between two plates. In between plates, you can write. In between plates. Between plates. So electric field at point P, net electric field means E net at point P will be equal to, Harsh, tell me if two vectors are in same direction.
Yes, sir.
What is the magnitude?
E1 plus
We will
E2.
E1 plus E2.
E2.
We will simply add these vectors.
Yes, sir.
So E1 plus E2. And we know due to the plate, the electric field is sigma y 2 epsilon naught. And due to negatively charged plate, the magnitude is again same, sigma y 2 epsilon naught, and we will get sigma y epsilon naught. So total electric field at point P is equal to sigma y epsilon naught. You can say total electric field. Total electric field. Now our 70-80% work has been completed. We have calculated the total electric field. We have calculated the total electric
Total
field.
electric field.
Total electric field. Now we have to calculate the potential difference or voltage. You can say potential between the plates. Potential difference between the plates. So if I want to calculate the potential difference between plates, first we have a formula of electric field is equal to minus dV by dr. E is electric field, dV
Yes,
is
sir.
potential difference, dV is
Yes, sir.
potential difference, voltage difference, and dr is distance. So there is one formula will come here. E is equal to, for the potential difference, I am writing V. So this will become V, and dr is the distance between the plate, D. We will take here D. It means this formula is derived from here. So if I want to calculate V, so I can write V is equal to E into D. E into D. And what is
Yes,
the
sir.
value of E? E total E. We will take the total E here. Total E is here sigma y epsilon naught.
Sigma by epsilon, sir.
Sigma y epsilon naught into D. And we know sigma is Q by A into D. Okay. So we have calculated the potential difference, or you can say voltage potential difference. So now if I want to calculate the capacitance of parallel plate capacitor, capacitance, I am representing this with C naught, because naught means capacitance in air when air is filled between the plate. So C naught is equal to V Q by V, charge upon potential.
Yes, sir.
Capacitance is charge by potential, na? So C naught, and you can take any of the charge from the two plates. Q charge is Q. We will take the magnitude of charge. Here Q charge is there on the plate. Charge is Q. And what is potential? Potential is Q by A epsilon naught D. Means from here I can write the value of potential QD divided by A epsilon naught. And this Q and Q get cancelled out. This and this get cancelled out. We will get epsilon naught A divided by D.
D.
So C naught means capacitance is epsilon naught A divided by D. This is the final formula. This is the final formula. So please learn this formula. C naught is capacitance of parallel plate capacitor when air is in between the plates. So please, we know this formula also, capacitance equal to charge by
Q by V.
Q by V. So please write down.
Yes, sir.
And here is air in between the plates. Air in between the plates. Okay, write down. So here the main thing is to calculate the electric field. Electric field is very important here. All things are easy. We can calculate the potential. E into D equal to potential. But the electric field is sigma y epsilon naught, total electric field in between the
Sigma
plates.
by, yes, sir.
Epsilon naught. And if we calculate the electric field outside the plates, we get the value 0. There is no net electric field outside the plate. So it means that the electric field is only in between the plates, and this is the capacitor, means to confine the electric field in certain region. The capacitor confine the electric field in certain region. Means like you can say electric field created the electric energy, can create the electric energy. Due to electric field we will get the electric energy, and means the energy or charge you can say that, you not a charge, you can say the energy is confined in a region
Yes, sir.
that is in between the plates. And make this diagram properly.
Yes, sir.
Here is one plate number one, and here is another plate number 2, and one plate is negative charge, another plate is positive charge. Have
Second
sigma
problem.
as have sigma as surface charge
Yeah.
sigma as surface charge density. Okay, now it's fine.
Yes, yes, sir.
But you have to remember that for a plate, when a plate is given and there is a charge on that plate, whether it is negative or positive. So if someone says to calculate the electric field at some distance, then the electric field is given by the magnitude of electric field is given by sigma by 2 epsilon naught, due to a single plate, due to a single
Single
positively
plate.
charged plate, single positively charged plate, or a single negatively charged
Negatively
plate.
charged. Right.
We have this concept in electric field and charges in the when we study the Gauss law, then there is a derivation of this there. You can get this from there if you want.
So, can you scroll down?
Okay. So you have to do the work step by step. First, you will calculate the electric field. From that electric field, you will calculate the potential, and from that potential, you will calculate the capacitance.
Yes, sir.
If derivation is asked in the examination, otherwise you should learn the formula. You should learn
Yes, sir.
only the formula. Formula you should learn. C naught equal to
Epsilon 0 A by D.
epsilon naught 0
A by D.
A divided by D. Epsilon naught 0 is the absolute permittivity of air. A is
Yes,
the
sir.
area of each plate. D is the distance between two parallel plates. Okay.
Yes, sir. So guys, scroll down.
And C naught air means capacitance
Capacitance
in
of the
capacitance when plates are placed in,
here.
means in between the plates there is air only.
Yes, sir.
Now what we will do, earlier there was air in between the plates. Now we will replace this air with some dielectric, with some dielectric. And dielectric, we know that dielectric is non-conducting material. Non-conducting material. So the value of electric field will change. The value of electric field will change.
Done, sir.
Okay. So now this is one capacitance of parallel plate capacitor when capacitance of parallel plate capacitor when dielectric is fully filled. Dielectric is fully filled. Okay. Capacitance of parallel plate capacitor when dielectric is fully filled in between the plates. In between the
Yes.
plates. So now what I am doing, so now this air is replaced by dielectric. Some dielectric of constant K. Now Harsh, you can see that these are two parallel plates capacitor. Now in between the plates, the dielectric is fully filled now. You can imagine that. You can imagine that. I am writing here also. Here. In between these plates, dielectric of constant K is introduced or placed. Introduced fully in between plates. Okay. Now, when we place the dielectric here, what will happen? See what will happen. Nothing will change. Nothing will change. Net electric field again will be equal to 0. Here also net electric field will be 0. Here the direction of net electric field will be 0. But only the values of electric field will be changed. Only the values of electric field change. Now the electric field E1 and E2 when dielectric is field will become E naught yk means Eyk. Eyk means you can write it like sigma y 2 epsilon naught and divided by k.
So just on my computer, my laptop is lagging. Just turn it.
Okay, no problem.
Yes, so you can continue, sir.
So Harsh, now it's okay.
Yes, sir. Now it's fine.
So you can see that electric field E1 and E2 now will become. We will divide the earlier electric field by k. Earlier electric field by sigma by 2 epsilon naught and divided by k, so it will become sigma by 2k epsilon naught. So that this is the thing I am writing.
Okay, sir.
E1 equal to E2 is equal to sigma y 2 epsilon naught into k. 2 epsilon naught. K is the dielectric medium. And at point P, now net electric field at point P, we have already calculated the direction. Direction will remain same. Direction will remain same due to this positively charged plate. The direction of electric field is in this direction. Due to this negatively charged plate, the direction of electric field is in this direction. So two vectors at point P, like I am drawing the point P. 2.2 vectors means E1 and again another here also E2 are in same direction. So E net at point P is equal to, I am representing E net with E, is equal to E1 plus E2. And this time what is E1 and E2? Sigma y,
Sigma
y 2 epsilon naught k,
K. Yes,
sigma
sir.
y 2 epsilon naught k. So this will become sigma y 2 epsilon naught sigma y k times of epsilon.
Epsilon.
So electric field at point P, or you can say E, is equal to sigma y k times of epsilon. So now we have calculated the electric field in between the plates when dielectric is filled. There is only one change. Now there is only one new term k. K is here. That is dielectric constant. Means we have divided sigma y epsilon. Earlier the electric field was sigma y epsilon naught. Now the electric field by sigma y k epsilon naught. Means the electric field is divided by k in this case. So if I want to calculate the potential, so we have E into D. What is E? You can convert this. I can write sigma is equal to charge upon area.
Yes, sir.
So I can write electric field as Qy A epsilon naught, or you can write Ka epsilon naught into D. Now from here I can calculate the capacitance Cm. Cm is the capacitance when some medium of dielectric or some medium is placed. Will we know charge by potential? Charge by potential. What is charge Q? Charge is Q on each plate. You can see
Yes,
from
sir.
here.
Plus Q, yes, sir.
And what is potential? Potential is QD divided by Ka epsilon naught.
Naught.
And Q get cancel out. You will get Ka epsilon naught by D. K epsilon naught by D. So Cm is equal to, instead of epsilon naught A by D, can I write C naught?
Yes, sir.
So this is the formula.
Okay.
Where C naught is equal to epsilon naught
Epsilon
A.
naught A by D, which is parallel plate capacitance.
Or always remember that for dielectric K is greater than 1. So K is greater than 1 means Cm is greater than C naught.
C naught.
So please note it down.
Yes, sir. Sir, okay.
It's fine now?
Yes, sir, yes.
So what we are doing when we are calculating the capacitance, so what we are doing, we are just calculating the electric field. We are just calculating the electric field in between the plates. And
Yes, sir.
from that electric field, we are calculating the potential difference. And from that potential difference, we are calculating the capacitance.
So can you scroll up a little bit?
Scroll up.
Yes, sir, just a bit.
Okay. Now it's fine.
Yes, sir.
Now, please remember one thing. Here, in between the plates, now in between the space of these plates, dielectric medium is fully filled.
Yes, sir.
Please remember that.
Yes, sir.
Earlier there was air, now there is dielectric.
Dielectric medium.
So dielectric is a non-conducting material. Non-conducting material. Dielectric is non-conducting material.
So I can just scroll down.
Fine.
Yes, sir.
At point P, I have drawn the point P like this. And we know that the point P lies inside the capacitor.
Yes, sir.
Point P is in between the plates. If the derivation comes in your examination, you will do derivation like this. Otherwise, learn only formula for the numerical purpose.
Yes, sir.
For the numerical purpose, learn only the formula.
Formula.
We will solve one question after this. This is not 6, this is sigma.
Yes,
Please
sir. Yes,
remember.
sir. Yes, sir. Sigma. Surface charge density.
Surface charge density. This is not 6.
Yes, sir.
This is point B. After the capacitance, we have very easy chapter.
Yes, sir. So can you just hold on?
Current electricity.
Current electricity, right?
Which is very, very easy.
It's easy.
Very easy. In comparison of electrostatic, the current electricity is very easy.
No, sir. Electrostatics was much easier. I studied current electricity also, but I felt the electrostatics was easy.
Okay, when I will teach you, you will find it very easy.
Okay, sir.
Actually, easy for you, not for me.
Yes, sir. We'll see.
Actually, actually, I am a teacher.
Yes, sir.
So if I will say things are hard for me, then what kind of teacher I am?
Yes. So you can just hold on.
Okay. Now it's fine.
Yes, sir.
So if derivation is someone is not asking derivation, learn only this
Just the
formula.
formula.
Capacitance in medium is K times of capacitance in air, or K is the dielectric constant of medium.
Medium. Done, sir.
Done. Now we have one question. And please try to solve this question by yourself right now. The question is, a parallel plate capacitor with air between the plates. A parallel plate capacitor with air between the plates has a capacitance of 8 picofarad, and 1 picofarad is equal to 10 to the power minus 12.
Minus 12 farad.
What will be the capacitance? What will be the capacitance if the distance between plate, if the distance between plate is reduced to half? and the space between them space between them is filled with a substance with a dielectric of constant 6. Constant 6.
Sir, just want to add the question.
Okay.
Done, sir.
Done. So let's see how we will solve this. This is a parallel plate capacitor.
Yes, sir.
We know one plate is positive, another is
Other
negative.
place is negative.
They have equal charge. And now initially the air is filled in between the plate and distance is d.
Yes, sir.
Distance is d and A is the area of each plate. So capacitance will be epsilon 0 A divided by D. Okay, epsilon
Yes, sir.
0 A
divided
divided by
by D.
D. No problem. And this capacitance is given as 8 picofarad.
8 picofarad.
8 picofarad given. 8 picofarad means I can convert
8
this
10 raised to
into,
minus 12 farad.
this is given to us.
Yes, sir.
And what they are saying now earlier the plates are like this at this
Yes, sir.
distance. Now the
Yes,
distance
distance
between the
reduced.
distance reduces and becomes half, and after reducing the distance some dielectric is filled in between the plates. So this is the initial condition, you can say.
Yes, sir. Case 1.
This initial condition. Initial. Final. What is the final condition? We will see. Final condition. We have the capacitor. Now we have reduced the distance to d by 2. And
sir.
this time this is positive plate, this is negative plate, you know that. And this time dielectric is filled, this time fully filled. If not given in the question that dielectric is fully filled or partially filled, consider dielectric
Fully,
is fully filled.
fully
Consider
filled.
dielectric fully filled. So for this, the capacitance is Cm is equal to
Cm equal to K, sir.
K into C naught.
Yes, sir.
C naught means uh, means K epsilon naught 0 A, and distance between the
By
two
D.
plates.
By D.
D means here D is d by 2.
D by, yeah, D by.
D by 2. So this will become 2K epsilon naught A by D. And we have 2K, and
Yes,
this
sir.
is epsilon naught A by D. This is 2K, and epsilon naught A by D is given to us. Epsilon naught A by D is what? 8 into
8,
10 to the
8 to 10 raised to minus 12.
this is 2, and value of K is 6. Now you can easily calculate and tell me the answer.
Yes, sir. Just a minute.
And this is dielectric.
Sir, 96 into 10 raised to minus 12.
हाँ ठीक है. Okay. 96 into 10 to the
10 raised to
power
minus 12.
and also mention the unit.
Farad, yeah, Farad, sorry. Done, sir.
Done, no? Okay.
Yes, sir.
So this is the question, and our next topic is we have 9 minutes. So third is parallel plate capacitor when conducting slab partially filled between plates. Means here also we will calculate the capacitance.
Yes, sir.
Here also we will calculate the capacitance. We can say that we have to calculate here capacitance. Like these are two plates, and these plates are like this in actual, but you are only seeing the front side. Like these are the plates like this. Earlier the plate. So you are now only you are seeing this part now like a straight line. You are
Yes,
only
sir.
watching this straight line. So this is one plate. This is another plate. This is negatively charged plate. And this time a conducting slab. A conducting slab is, this is a conducting slab. Of thickness T. And the distance between the plate is D. This is conducting slab.
Yes, sir.
Conducting slab is placed. And we know that electric field inside the this is conducting slab means this is conductor, and we know that electric field inside the conductor equal to 0.
Yes, sir.
Electric field inside
The conductor is 0.
conductor or conducting slab is 0. So now the electric field will be in this region only. This region
Yes, sir.
will be in this region. And this in the region, the thickness of this region is equal to d minus t. The thickness of this region is d minus t. And we already know that if I calculate the electric field here, we will get the value. Here is air. In this region there is air. Here also the air. Here also the air. Yeah. Means the region apart from the conductive slab is the region of air. And what happens when we calculate the electric field in air? Electric field in between the plates in region of air. That is, I am supposing is that E. You can say here EC. This is EC. E, and this E is, we have calculated many times, sigma by epsilon naught.
Yes, sir.
And this is for thickness. D minus T only.
Yes, sir.
This electric field is only in thickness of D minus T.
D minus T.
Because here is this, and only
Yeah.
thickness left is this.
Yes, sir. It will be D minus T.
Okay. And so now E is sigma by epsilon naught, and sigma is Q by A epsilon naught. I can calculate V is equal to ED, E into thickness, E into
Yes,
dr means thickness, into D minus T. Why I am taking this time D minus T instead of D? Because the electric field, here is the electric field 0.
Yeah.
And electric field is only the region of, so you can
D minus T.
So you can put the value of electric field here, Q divided by A epsilon naught D minus T. And we have now calculate the capacitance, see, Q by V.
Yes, sir.
And we have already discussed, here is plus Q charge, here is minus Q. Take any one charge, magnitude of charge, Q, and what is V? V is equal to Q by A epsilon naught
D minus T.
D minus T. And Q
cancel
out. So C will become epsilon naught 0 into A divided by
D minus T.
So this is final capacitance when a conducting slab is placed in between the plates.
Parallel capacitor.
And the thickness of this plate is T.
Yes, sir.
So please note it down.
Yes, sir.
Harsh, are you studying in your free time?
Yes, sir. I'm studying
these days.
Yes, sir. We have vacation, that's why I have to study.
I know there are vacations, but after
Yeah, yeah,
enjoying,
I am studying. I'm studying, sir, all day
okay,
because
good.
I only play in the evening. That's it.
That is very good. But after enjoying 10 to 12 hours, you can study 2 hours. That is enough, I think.
No, I studied 8 hours and then enjoy two
Oh,
hours. Sir.
oh, I don't think so. You can
No, no,
study.
I wake up in the
Okay,
morning 7, then I study till 12.
so
Then
means
I
you
do my
are
tuition
very.
and then get up there.
So it means you can break all the records of CBSC
Maybe,
in the coming years.
maybe.
There will be the photos of yours on social media like Instagram, and like has stopped the examination, got the marks 101 from the 100.
Yes, sir.
Okay, definitely this can be happen. You can get the 100. You cannot get the 101 marks, but you can get at least 100 marks from the
Yes,
100.
sir.
Have you understood this? How I
Yes,
have
sir.
done this? This
Yes,
is
sir.
nothing. Just you have to think. You have to think. Means you can imagine. No, please see here one. See here one.
Yes, sir.
This is the plate. These are the two plates, and in between these two plates, what I have done, uh, I have placed some conducting slab in between the plates. So the electric field in a region of
Field is zero
conducting
inside the conductor, so it will just be
in
on
the
the
region of
outside.
in the region of
Yes.
conducting slab, the electric field is zero, but there is an
Yes.
electric field in between the air, where, where the air is in between the plates. Okay,
Yes,
so
sir.
that electric field we are calculating. That electric field we are calculating.
Second scroll down.
Okay.
That's
Okay.
it. That's it. Yeah, sir. That's it.
So now please note it down and
Sir, just little bit up, sir. Little bit up.
okay,
Just one line up.
okay, no problem.
That's it. Thank you, sir.
That's fine. So what we are doing, we are just calculating the electric field, and after that we
Yes,
are
sir.
calculating the potential,
Potential.
or after that we are calculating the capacitance for any case.
Capacitance. Yes,
For
sir.
any case.
Electric potential and then capacitance.
And the formula of electric field is sigma by epsilon naught symbolic.
Yes, sir.
And in case of dielectric, the formula changes to sigma by k epsilon naught.
Yes.